So 45 divided by that scale factor gives you 9. Okay, so if you can notice the scale factor, you can do it that way as well. The only problem with that is that if the scale factor is not a whole number, then the problem can't be done that way. Or it can, but it's just harder to see what the scale factor was. So what I'm saying here is another way to do this is say, this corresponds to that, right? So in order to get 15, we can take 3 times 5, and we get 15. So here, what number times 5, because it has to be the same scale factor, gives you 49. So that's where the 45 divided by 5 gives you 9, and that's what answers it. You can absolutely do it like this. You just have to make sure that you're going from corresponding side to corresponding side. And of course, like I said, if this is not a whole number, then it might be a little harder to see it. Okay? So, next, slide number 3. I asked you guys to fix it if you have to fix it. I'm going to share. So the ratio of corresponding side lengths of two similar MP3 players is 4 to 3. The area of the larger MP3 player is 8 square inches. What is the area of the smaller one? Here's the similarity ratio, 4 to 3. Okay? Here's my similarity ratio. Because this is an area problem, we must first raise our ratio to the second power. Okay? So 4 to the second power is 16, 3 to the second power is 9, and then we set up our proportion. Here is the ratio of the areas, and then this information here, it was given to you that the area to match two angles from one triangle to two angles. Triangle, remember all the angles in a triangle add up to 180. So I'm going to do 180 minus 26 minus 90. When I do that, 180 minus 26 minus 90, I get 64. So that means the angle measured for E is 64 degrees. Now at this point I could answer the question, but I'm going to go ahead and continue working and solve for the measure of the other angle here. I'm going to solve for the measure of angle K in the other triangle. And that is also 180 minus this time 64. When I do that, I get a measure. Okay, so let's get used to solving first for the missing angles. So I know now that angle E is 64 and I know that angle K Some good answers right here. It's a lot. I've got some good answers there. So let's just go over it. If you didn't finish, you can take a look at what we're doing and then see if you have any questions. Okay? So the problem is asking to determine if the two triangles are similar. So we're going to apply the theorem. We're going to look to see if we can match two angles from one triangle to two angles of the other. When I'm looking at the two triangles, I can see that here y is missing and then s is missing. So before I do anything, I'm going to solve for those angles. Okay? So I'm going to say the measure of angle y is equal to, I'm going to say 180 minus the 99 minus the 21. And I will get that the measure of angle y, excuse me, is 60 degrees. Angle y is 60. And I'm also going to solve for angle s. The measure of angle s is equal to 180 minus 61 minus 21. And that's going to be equal to 98. So this angle right here is 98. Okay, so now I have all three angle measurements. I can look to see if I can match some. So to that s,